In this video, I wanted to go over the connection between the engine and the PCU. So I have the PCU up here on an older EDC A, B, or C version. The PCU, again, is mounted in the engine, or later models, the PCU is mounted on the engine, such as EDC C2, C3. We'll cover later versions later. So, first thing is the 8-pin harness connection that goes into the engine. The other end is the X3 connection. So in the service manual, it shows an 8-pin connection. That 8-pin connection, only 5 of the wires, 1 through 5, are being used. Those wires being the first 2 wires, pins 1 and 2, are your CAN 1 bus wires. That's the communication information between the ECU on the engine and the PCU here. Your X2 data link is your next CAN bus connection that goes up to the ELM, which is to the HCU. So this connection, so if I had a problem where I had an ECU communication failure with a PCU, so mid 128 to mid 187, or I had a PCU communication on CAN 1 to mid 128. Either direction means that I have a communication problem with these 2 CAN wires. Now, the other wires are a black wire, a red wire, and a blue wire with a red tracer. So, power, red obviously, black, ground, and then the blue wire with a red tracer is basically what they call key ignition on. So when you turn the key on up at the dash, the HCU then commands the CAN bus signal down to the PCU, and then the PCU will take the power supply that it's receiving from the engine and turn around and run it back through that blue wire with a red tracer. The other end of that wire branches off and goes to the excitation of the alternator. So if you look on the back side of the alternator, you're going to see that blue with a red wire. So if you're up on the dash, you turn the battery switch on, you turn the key on, and nothing happens, it lights up, but the engine doesn't respond, it won't crank, nothing like that, then maybe the ECU is asleep. So you want to check that wire to see if you have power on that excitation wire. Now I'm going to show you how to do that with a breakout box, and we're going to go through that right now. So the first thing I'm going to do is I'm going to say, all right, I have a problem with the PCU communication to the ECU. So I'm going to get my breakout box, my 62-pin breakout box. I'm going to get my Deutz connector 8-pin breakout. I'm going to take my engine connection, disconnect it, plug it into the breakout box, and then I'm going to plug my breakout box into that 8-pin connection. Only goes one way, you can't mess it up. Unless you hit it with a hammer, maybe. Okay, so you could hear the engine wake up when I plug that in. I've got the battery switch on. Now what I'm going to do is I'm going to look in the wiring diagram to figure out what those 5 pins are. Now, those 5 pins out of 8 means that's an 8-pin connector, Deutz connector. So if you remember from previous videos, the connectors are 2, 3, 4, 6, and then 8. So we ended up on 10 was the beginning of the 6-pin. So 1, 2, 3, 4, 5, 6 ends at 15. So the 8-pin connector starts at 16. So 16 is pin 1, 17 is pin 2, and we only need those 5 wires. So 1, 2, 3, 4, 5. So pins 16 through 20 are the 5 pins that we're going to test to see if we have problems with power, ground, key on voltage, or our CAN bus circuit. So first let's look and see if we had a communication failure. We want to see if we have any issues with those CAN bus wires. Now I haven't taken them apart, I haven't messed with them, so we're going to have good data right now. So that way you can see what good data looks like on a communication. I'm going to go turn the key on, and then we're going to test those 2 wires. The next thing I did was I went into the service literature and I found the page on the PCU configuration for my X3 connection. I need to know what those wires are in reference to these 8 wires. So what I did was I took those those wires here and those connections, and I cross-reference them to the actual engine page, which is the wiring diagram. And that is going to be my 8 pins up here at the top of the diagram. That goes to the EVC, so that's that harness connection. So I have those 5 wires, 1, 2, 3, 4, 5, which are, the first 2 are can high, can low, battery negative, battery positive, and the key switch, ignition key switch on. What I did was I made a little cross-reference here, so easy, so I can do that. 5 minutes, I know what those color wires are, I know what those pin wires are, and then I know where they go into here. X3, 17, 7, 14, 28, and 23 in sequence. All right, so I can easily figure out what those 5 wires are and understand what I should see. So we're gonna simply turn the multimeter on to DC voltage. And what I'm going to do is try to zoom in so you can see a little better. Okay, so I'm going to take my meter leads. I'm going to take my little cheat sheet. I'm going to use my cheat sheet, and the first thing I want to do is I'm going to say, okay, again, 15 is the first pin. So if I go back and I think, okay, where am I at? I've got my 1 through 5 wires, and that's going to be 10 through 15 is my 6 pin. So 16 again through 20 is 1, 2, 3, 4, 5, all right? If you wanted to, you could even take a marker and mark them. They make overlays for this too. All right, keys on, I'm in milliamps, so what I can do is I can change my scale here if I want to on my meter to 2 decimal places, so it'll be easier for you to see what happens. So I'm gonna check power and ground first. So power is pin 3, or excuse me, ground is pin 3, and power is pin 4. So I start with 16 as pin 1 again, all right? And pin 3 and pin 4. So 1, 2, 3 is ground, that's pin 18, and pin 19 is power supply. So I have my battery voltage there, that checks out. The next thing I want to do is check if my key on wake up voltage is there. So if I want to check that, what I'm going to do is I'm going to say, okay, that's pin 5. So I'm going to simply move over here to pin 5. And I should see pretty much battery voltage here. So what I'm going to do is shut the key off, wait for the system to power down, turn the key back on, and you'll see the voltage come back. That's your key on voltage. So I've shut the key to the off position. The engine should start shutting down, and it did. So now my voltage went to 0. I can come back and see, do I still have my voltage on power and ground? Yes, I do. All right, now, let's say when you turn the key on, you don't get anything out of the ECU, so maybe that voltage from the PCU going into that blue and red wire is open, or there's something wrong with the ECU. So what I want to do is put it on that number 5 terminal, which is pin 20, and I'm going to turn the key on, and I should see voltage. In the event I didn't see voltage, then I know there's a problem in that wire. Now at that point, you know, you're right here, so you're already back probing into that connection. You might want to take the cover off, you might want to get into the PCU or the ECU harness and find out where that wire goes. That again would be the engine diagram. Easy enough to look at. I can come down here and I can trace that blue wire. That's number 5, and that goes right to pin 39 on the ECU. So now let's look at the CAN wires. We already know ground, and we know 16 and 17 are CAN wires. So let's check those real quick, and I'm going to turn that over to now frequency. So we're going to look at the frequency of pin 1 and ground. Okay, and again, that's K, so that's thousands of hertz. So 13, 14, yeah, between 13 and 14,000 hertz. All right, that's the frequency of the CAN bus signal. Let's try 17, the other CAN wire, and see where we're at there. Almost identical, 14 to 15,000 hertz. So that tells me those 2 wires, that's your good communication frequency. So frequency really is what I like because it gives you a good picture of the square wave and the intensity of this square wave. So I know that without an oscilloscope, I can actually see if there's data here. And if you write that down, you know, 14 to 15, so you've got good frequency there. The other end of the wires goes to 7 and 17. So if I look at my sheet, yep, can high is pin 17 and can low is pin 7. If I want to go look at those connections, then I need this PCU break-in, all right? So I would plug that in there, and then I could plug this into the breakout box, and then I can look in the book and see which pins that is. And that's going to be pin 7 and 17 because they're sequential. So you could check those to ground as well that way. I hope that this helps you understand a little bit more about, you know, CAN communications between the ECU. So the X3 connection is this connection. So this connection to the X3 connection is your CAN communications. That's externally mounted on an early version engine. Later version engines, the whole engine wiring harness is all incorporated, and the PCU is going to be mounted on the engine. So that's one major harness, is the engine harness. This is a separate harness, which is just more wiring for the boat builders, and that's why they decided to mount the PCU on the engine, to make it so all you need to come off the engine is this harness up to the dash. That's it. Just your X2 data link. So next time we'll get into a little bit of diagnostics, maybe on the engine and some of the running conditions of that. I think I've gone pretty well through the CAN 1 harness, which it's called, and the X2 data link harness, which is your CAN bus. So that's your X2 data link CAN bus from the PCU to the HCU, which is the helm, from your PCU, your X3, and your CAN 1 CAN bus harness to the engine, to the ECU. So two separate CAN bus harnesses in communication. Coming off, the last thing off this harness is also your data link. So your data link is coming off that, and on the main engine harness, when you plug that into the engine, this is your X2 data link, or excuse me, this is your data link harness that you plug Vodia into. So there are two J1587 pins that are coming into here. This would be your communication link to that. And you can break right into this in the breakout box if you're having problems with your diagnostic tool to see if you have J1587 protocol there. And I'll give you some numbers on that too. Till next time.